Welcome to this screencast on developing with the Microsoft Graph. Let me first talk a little bit about what this screencast is and what you can expect from it before we start diving into the content. This screencast is going to accompany a hands-on lab and a training module that you can take advantage of that goes along with everything you're going to find in this screencast. Specifically, you're going to find in this screencast is really going to be an example of someone presenting the content from the training module as a way for you to learn how you could use this module and delivering it to a different user group or at a conference. However, you can also use it as self-paced learning. Now, the way that this module is set up is that it's broken up into a series of a couple different sections. We'll go through each one of them in just a few minutes. Each one of these sections is going to finish with a demonstration. Now, the demonstration, we don't walk through the entire step of creating the application or walking through the steps of writing all the code. Instead, we look at the final solution that has already been built and kind of pick through the code and pick through the important parts that you should take advantage of or you need to take note of. And we'll see it working as well. If you want to go through and you want to build the application, you want to see how it's being built, then what we would recommend that you do is go check out the hands-on lab that accompanies this module. Because the hands-on lab, each of the exercises maps to one of the demos inside of this screencast that you're going to see. So if you want to see how to build it and you want to walk through the steps, you can walk through the hands-on lab exercise that accompanies this module and get to the exact same place that we're showing you here in the screencast. Instead, we're not going to show in the screencast all the individual steps of creating the application. And part of that is because things change on a rapid cadence, and the lab is going to have the most updated steps and dependencies and stuff that you're going to need. The screencast is more or less showing you how the thing works or how the final solution works. So that's how you can learn more about taking advantage of this content and how we've structured this. Let's go ahead and dive into the actual module itself. In this section, we're going to talk about building universal Windows platform applications with the Microsoft .NET SDK. This first section is going to be mostly an overview to the Windows universal platform and understanding the Microsoft Graph API, how we can get started with this, and then what the process is for creating a UWP application for Azure AD and the Microsoft Graph. In the future sections of this screencast, we'll then look in a little more depth about authentication and in the Microsoft Graph specifically. Office 365 Developer Vision focuses on the user's experience and their data. And as a developer, you can bring your application into the user experience. With over 1.2 billion users of Office worldwide, this is a huge opportunity to provide a window into your application, as well as being able to connect into their data and add intelligence to your application. There are currently over 850 million events created each month and a total of over 400 petabytes of data stored in the service that can add value for your users. The Microsoft Graph is the gateway to your data in the Microsoft Cloud. As you see there from the bottom of the list, we've got a lot of different services and data types that we can actually take advantage of from Office 365 and Microsoft. And it's all considered part of the Microsoft 365 platform. We can work with mail and calendar, contacts, tasks. We can work with content inside of SharePoint sites and lists, files inside of OneDrive, things inside of Microsoft Teams, users inside of Azure Active Directory. There's so many different things that we can take advantage of. The nice thing here is that each one of these different services usually has its own API where we can talk to these different services to get the data out. It can be challenging to go get the data from all these individual services as they each have their own endpoints, they may have their own permissions, and that also means that with their different access control that we have and talking to these different services using an OAuth style authentication via Azure Active Directory, that means that each one of these different endpoints is going to have to require their own access token. One of the nice things about the service called the Microsoft Graph is that the Microsoft Graph is going to serve as a proxy endpoint to all of these other different services. It's going to encompass things such as Office 365, Windows 10, and Enterprise Mobility and Security. And it brings all of these different services under one top-level service called graph.microsoft.com. The advantage to using the Microsoft Graph is that it's going to allow you to just have a single point resource, which means you're only going to need a single access token to be able to talk to all of these different services. They still have their own individual permissions, or as we refer to them as scopes, so that everything is still secured in a very individual way. but this makes it easier for developers to build applications. All Office 365 cloud services, including SharePoint Online and the Microsoft Graph, leverage Azure AD for authentication and authorization. This means there's a single authentication flow that you can use inside of your Office 365 applications, as well as those created to leverage the Microsoft Graph. This single authentication flow means that we're just going to have one way that we have to log in to all of these different services and obtain an access token, either using a web application or a native application. It also has a whole consent model. We'll look at that a little bit more in a future section. Everything is also very secure. Everything is based off the OAuth 2 protocol, which means that the application that you build is never going to collect user credentials. We're always going to redirect them over to Azure AD, have the users log in, and then Azure AD will provide my application that I can build as a developer with a special code that the application can then use to exchange for an access token to be able to call these different endpoints and services, such as the Microsoft Graph, on behalf of these different users. We also have some very fine-grained permissions, otherwise known as scopes, so that users can only grant the application specific permissions of different things that they want to allow the application to do. And then we can also have some special considerations that we have to take into account if we're building native applications. So there's some things like when you build a web application, you have a client ID and secret. You can protect the secret because there's server-side code that the web application doesn't have to expose to the end users. But as we'll talk about a little bit later, the native applications do have a little bit of a challenge where once the code has been distributed, we can't include both the client ID and the secret, because if we distribute the secret, well, technically it's no longer a secret anymore. We'll see how this works in a native application in just a little bit. Now, Office 365 has a single authentication flow for Office 365 and the Microsoft Graph. Users are going to sign in using a technology called OpenID Connect, which is an open standard. And what that does is that once people have logged in, there's this nice little envelope wrapper that will include details about the individual who's just logged in. Azure AD is going to be used for all of the authentication. The Microsoft Graph is built on top of the authentication model of Azure AD. Office 365 is also built on top of the authentication model of Azure AD. So both of these services trust Azure AD. By having this single level of trust or single service that they both trust, then we can leverage the authentication to take advantage of both of these different services with the same authentication flow. This authentication flow is also going to support multi-factor authentication, also referred to as MFA, and federated user sign-ons. And it's going to support all different kinds of applications, from device applications such as those on a mobile device, websites, single-page applications that live 100% in the client, or as a headless application with no user involvement, also referred to as a daemon or as a service-based application. You'll be able to pin applications to your Office 365 app launcher from the My Apps page, which is like that little menu that you have in the top left corner within Office 365. Platform convergence has been a journey which ends with Windows 10. Microsoft started by using the same Internet Explorer code and engine on Windows Phone 7.5 and Xbox 360, and then they started implementing the Microsoft Modern design at that time. With the release of Windows 8, Microsoft converged on the Windows kernel, which aligns, among other things, the hardware extraction layer and the driver models. Windows Phone 8 also took advantage of a new lighter weight kernel to enable CPUs and other improvements, and the Xbox One was then built on top of Windows 8. Xbox also introduced something called XJS, which is Xbox version of WinJS, so developers could write apps in HTML and WinJS in the same framework as was available on Windows 8. With the release of Windows 8.1, the runtimes for Windows 8.1 and Phone came together as well, continuing up the Windows stack and building upon the kernel convergence that happened in Windows 8. Now, aligning the app models and API set, this brings 90% of the API convergence and unification convergence of things like Windows notification services and the backstack behavior, sharing contacts, live tiles, etc. Now with Windows 10, Microsoft is going to bring a complete or is going to complete the process of the unification of all the Windows families. And it now provides a Windows core that can be used on embedded devices and IoT devices. This makes it very easy for developers. Now they can just use one central platform that we can use on all different Windows-based devices. To bring the families together, Windows 10 is built on top of a unified core, the Windows Core, and a unified app platform, the Universal Windows Platform, which means that all of the device families that run Windows is going to be at the core. This provides a consistency that users need and the tailored experiences that they desire. Gone are the days of Microsoft maintaining a number of code bases that work to build the bridges across the different silos. Now Windows has evolved to do all that itself. And also gone are the days of ISVs having to build this as well. Targeting Windows provides a single roadmap to a billion plus Windows different screens. Now, enabling this consistent yet tailored Windows experience are a number of different services that you see at the bottom. You've got an adaptive UX, which is a user interface design that is going to adapt and react to the device family that it's running on. Natural user input such as speech, natural ink, gesture, and facial recognition. Cloud-based intelligence services such as Cortana, Personal Hubs, OneDrive, Office 365, the Windows notification services, and a credential locker. And the Windows Store, universally available apps, games, and digital media. For the application developers and builders, this also means that you can build on one Windows solution that runs across all of the Windows device families and use these Windows services to tailor your experiences at runtime. Now, this is all tailored, even though that you have this unified kind of experience, you're going to be able to leverage the different experiences that have been tailored to different form factors. So you've got Windows PCs, which are like a familiar desktop-based application where you have like the broad support of the ecosystem, the hardware ecosystem, and Windows desktop application capabilities. You've also got Windows for phones, like as a familiar mobile shell and rich telephony and Windows Phone app capabilities. Windows on Xbox, which is a 10-inch shell experience, or 10-foot, shell experience, and shared gaming experiences, game and app capability. And then you've also got Windows for different things like form factor appropriate shell experiences, like device-specific scenario support is also part of this entire platform. All of this is based on one core operating system with a base OS, app and device platform, runtimes, and also different frameworks. So if I talk a little bit here about the adaptive UX that we looked at, or that I mentioned earlier, what's nice about this is that you're going to be able to build the same code using the same controls, and they're all going to be rendered out based on the platform that you're currently on. So in this case, you can see what looks like Skype running inside of a mobile device, as well as inside of a tablet or a Windows device. And you can see how the same code base is being rendered out in different ways. For the different tailored experiences here, you can also see how you've got a based on the screen real estate, you can show a different experience. So here, based on a set of adaptive controls, you can then enable a tailored experience that goes just along with that device. Now, one of the nice things about this is that you're just going to have one binary that you're going to build for all of your different devices. You no longer have to have a shared project and specific platforms project that are going to use the shared business logic in the shared project. You've got no more conditional code like if I'm on this experience or that experience. And you also have one universal store. This is really nice because the Windows Universal Platform is then going to be available to you on every Windows 10 device, which is going to make the deployment model also much, much easier. Now, what is the Windows Universal or the Universal Windows Platform, the UWP? It's a collection of a bunch of contracts and extensions so that when you create an application, you're going to target a version of UWP and not target the operating system instead. You also have a bunch of platform extensions, which are different SDKs to add specific platform APIs on top of the Universal Windows Platform. So how do we go about creating a Universal Windows Platform application? You're going to do this using Visual Studio. So you're going to first create the user experience, and then in the context of trying to get data out of the Microsoft Graph, you're then going to extend the app to support some sort of authentication and token acquisition from Azure AD. And then you're going to integrate something like the Microsoft Graph .NET SDK. You can also create, when you go to create these UWP applications, so this is just showing you what the experience looks like. So on the left-hand side, you're going to create the app inside of Visual Studio, and then you implement the user experience and test it prior to implementing authentication and integrating the Microsoft Graph. So in this first demo, what we're going to see is how to go about building our first UWP application. It's not going to do a whole lot. We're just going to get the user experience set up so that we have a good flow for how everything's going to work. All right, in this first demo, we're going to take a look at our application, our UWP application. Now, just as a quick reminder, as I've explained already, we are not in the screencast. We are not showing every little step about how to create the application or how to, or all the typing that's involved for writing the code and copying and pasting code and all that. Instead, what we're doing is I want to show you an existing application and what we did to actually get this to work. If you are interested in learning more about not only seeing the final solution or to see how to create the application yourself, check out the training module that is associated with this screencast, as we have full code samples of the final built solutions and a step-by-step detailed hands-on lab that is going to walk you through all of the steps. And we do it this way so that the videos don't get out of sync and they're a little more timeless. Whereas we may need to update things for different version numbers and the developer environments may change slightly. And so we need to make little changes here and there to make sure things are all going to work accordingly when you go through and you do the lab. Now, I've gone ahead and created an application. When I did this, I selected a C#, and just show you new project. I created a brand new project. I chose the C# Windows Universal in a blank app application. So I chose that. And then once I did that, when I was prompted, I chose a version of the UWP that I wanted to target, or a minimum version I wanted to target. Now I also have added in a couple different references to this. So I've got references to a couple different UWP control toolkits, the community toolkit that we have. This is going to allow us to get some UI controls for in-app notifications and loading indicators. The grid is going to be used to show data that we get back from the Microsoft Graph eventually. And the last one for the graph is going to be able to show us the login and access token retrieval. And then I've also added in a reference to the Microsoft Graph .NET SDK or UWP SDK as well here. Now, once those have all been installed, I then went through and I started setting up the app. So first, if I take a look at the code behind for this, inside of app.xaml.cs, I've created a new property here called isAuthenticated. And that's going to be something we use to determine if the user is currently authenticated or not. Now the app is first going to load this main page.xaml file. So this guy right here, what he does is he contains a basic navigation view element with both a home controller and right here there's our home controller for different menu items and a calendar controller as well, these different navigation links. They're going to act as the main view for the application. It's also adding in this Azure AD login control to the header. That's going to be controlling the user sign in and sign out controls. However, this doesn't work at all right now, and it's not fully enabled because we haven't done anything with Azure AD yet. We're going to do that in the second section. Now, I've also gone in and created a new XAML page here called home.xaml. And this is going to just contain two text blocks of some text to display to the user when they first navigate to our application to show them something by showing something by default. Now, inside the code behind for this main page, what you're going to see is I've set in the main page initializer. I've got a set auth state and a root frame.navigate method. Now, the set state is going to set the current authenticated state of the user, and then the navigate is going to go straight to our home page that we've defined. For the set state, we've got a method here that allows us to set the state. That's what's being called up here. And what this is doing is allowing us to set if the user is currently authenticated or not. And if they are authenticated, then I will, regardless, I'm going to save it. And then I'm also going to save their authenticated state. I'm going to set that equal to the isEnabled property on the calendar view. Should it be available or not? And that's the navigation element that we have. And then here, when I navigate, I want to navigate to the calendar. Well, right now we haven't implemented that. But if you navigate to the home page, I want to take you back to the home page. So let's run this and see what it looks like. So I'm going to go ahead and click on the local machine or F5 to get this running, and now you can see our default application. There's the text for the application, and then there's the please sign in to continue, and then I've got my sign in button right here. There's my home and my calendar. And if I click on calendar, nothing's happening. Click on home and actually get taken here to home. I was already here. So that's the very simple first step of creating our application. Let's jump back to the slides and let's talk a little bit about Azure AD and authentication, and that will be our next step for our application, is to go extend this to work with Azure AD. In this section, we're going to look at how to implement Azure AD authentication into our UWP application. We are first going to start by looking at an overview of what the authentication story is going to look like. Then we'll talk a little bit about the Azure Active Directory, and then we'll talk about the app registration process that we're going to use the Azure AD admin portal to do that. And then finally, we're going to talk about using the Microsoft Authentication library to handle all of our authentication. All Office 365 cloud services, including SharePoint Online and the Microsoft Graph, leverage Azure AD for authentication and authorization. This means there's a single authentication flow that you can use inside of your Office 365 applications, as well as those created to leverage the Microsoft Graph. This single authentication flow means that we're just going to have one way that we have to log in to all of these different services and obtain an access token, either using a web application or a native application. It also has a whole consent model. We'll look at that a little bit more in a future section. Everything is also very secure. Everything is based off the OAuth 2 protocol, which means that the application that you build is never going to collect user credentials. We're always going to redirect them over to Azure AD, have the users log in, and then Azure AD will provide my application that I can build as a developer with a special code that the application can then use to exchange for an access token to be able to call these different endpoints and services, such as the Microsoft Graph, on behalf of these different users. We also have some very fine-grained permissions, otherwise known as scopes, so that users can only grant the application specific permissions of different things that they want to allow the application to do. And then we can also have some special considerations that we have to take into account if we're building native applications. So there's some things like when you build a web application, you have a client ID and secret. You can protect the secret because there's server-side code that the web application doesn't have to expose to the end users. But as we'll talk about a little bit later, the native applications do have a little bit of a challenge where once the code has been distributed, we can't include both the client ID and the secret, because if we distribute the secret, well, technically it's no longer a secret anymore. We'll see how this works in a native application in just a little bit. And the application then, in the top left corner, will be able to take that authorization code and then go log into Azure AD and provide it this code and say, I need an access token for this user. Azure AD is going to look at that code and say, I can tell that this is a code that I created, I being Azure AD, because it was digitally signed by Azure AD with their private key. So they know that the contents of the code are valid because it has a digital signature that matches one that only Azure AD could have signed. So it trusts that service. So it will then take that code. It knows that in that code it says things like it was the user was me. They're trying to access the Microsoft Graph, and that it's coming from this application, this native app. So Azure AD will look inside of his database and say, has this user granted this application permissions to the Microsoft Graph? And the answer is yes, because that's what we just did. It will then create an OAuth access token, and it will hand that back in that diagonal line going from the bottom left to the top right that says issue token. It will send that over to back to the native application. And that access token will contain the user. It will contain the resource that the token is valid for, in our case, the Microsoft Graph. And it will contain all of the scopes or permissions that the user granted the application. And now, from the top left corner, the native app can then request make an access data request over to the Microsoft Graph. That's the horizontal line across the top going from left to right to the resource server, the Microsoft Graph. The Microsoft Graph will get that token, it will look at the token, and it will say, is this token valid? It knows it's valid because it's going to look at the digital signature, and it knows that it's going to be able to match the digital signature against the public key that Azure AD uses, because the only thing that's going to match is the private key that Azure AD uses. So Microsoft Graph can say, I trust that this access token was created by Azure AD and the application's giving it to me. It's then going to open up that access token and know that I can see that this is a request for this specific user. This access token is intended for the Microsoft Graph, and it has these permissions. So it will then access the data that's being requested and then hand that back to our native OAuth client, our native application. And that's how the whole authentication dance and authentication flow is going to work here. You notice here that both the client and the resource server need to know about the authorization server, which in our case is Azure AD. Let me talk a little bit about different endpoint versions that we have in Azure AD. We have a V1 endpoint and a V2 endpoint. V1 came first, obviously. V2 came second. Now, how did this work? Well, in the V1 endpoint, there was two characteristics to it that are worth noting here, and why we don't use it in a scenario for the Microsoft Graph anymore. One of the scenarios is that Azure AD only supported, in the V1 endpoint, only supported the Azure Active Directory authentication. It did not support any other styles of authentication. And so what that meant is that if the user was logging in with a personal account or consumer account, also known as a Microsoft account, and they wanted to access things like their OneDrive consumer account or their Outlook.com account, things like that, our application would have to know what kind of account they were signing in with, and we would have to send them to a whole different authentication model. So that's one downside, because Azure AD or the V1 endpoint only supported work and school accounts or accounts with that leveraged Azure AD. The other challenge that we had is that with a V1 endpoint, it required what's called static consent, which meant that every single permission that our application was going to need when the user first logged in, they were going to have to grant all the permissions up front at that time. They had to declare everything at the very first time. But what that's going to allow us to do then is that we don't have to worry about that extra complexity. We're going to let Azure AD figure all that out for us. So that's one nice thing. That's the first 2 points. Converged authentication accepts sign-in for both Microsoft personal accounts and Azure AD Work and School, and it enables the same code, the code that we write, for using the Microsoft Graph for things like reading mail and retrieving contacts. Now, the next thing that's really important here is the dynamic consent. And what's nice about this differs from V1, where we had static consent, where now every time you go to request a access token from Azure AD, you specify the permissions that you need for that access token. Now, let's say, for example, in the example I gave a minute ago, when the user went to log in, they had to grant all permissions that this application could possibly need up front. Well, now, when the user signs in, all I really need to do is I just need to request the user impersonation scope, and that's going to allow me to get information about the current user, just get their name, their email address, etc. And now they get a much better experience when they log into my app. Maybe they're only going to use the capability to reorganize their email into different folders. When they go to do that, I can request another access token that says I need mail.read and mail.write. And when I do that, then the user is only going to be prompted for those permissions if they had not already granted those permissions to the app. The next time they go to use the app, same thing. It's going to go check to see, we need these permissions. Azure AD says, I can tell this user has already granted those permissions, so we don't need to go through that whole process a second time. But we don't have to request permissions for their calendar, for their tasks, or for their files in OneDrive. We only need to ask for that stuff when they actually need it. So I think that's a better experience because your users aren't hit with a lot of stuff. And you've seen a similar model with this, like on your mobile devices. An application may, like if you were going to use one of these social apps and you wanted to post something to this social network, let's say you just want to post some text. Well, it doesn't need a permission for that. But then if you wanted to, say, post a picture that you had taken, they need access to your photos on your phone. And so it prompts you for, do you grant this application access to your photos? Yes or no. The next thing is maybe I want to take a picture and have it send right away. So then it's going to ask for permissions to your camera. Or you want to do a little video. So now it wants permissions to your camera and your microphone. If you had installed the app and the first time you went to log in, it says, I need access to your microphone and your camera and your photos, you may be a bit turned off by the app and say, I don't want to give you all those permissions. I just want to post some text to this social network. That's what dynamic consent is all about. It allows you to incrementally just grant these permissions. And you can learn more about the V2 endpoint if you go to aka.ms/aadv2. Now let me talk about some of the other improvements from the V1 endpoint to the V2 endpoint. In the V1 endpoint, you had to provide a resource parameter to identify which resources you were requesting an access token for. And the challenge with this is that some of the open source libraries were not able to easily incorporate that into their requests. So now we use the scope parameter, which is supported by all the libraries to compound and combine both the resource and the permission. When you build applications with Azure AD V1, you also had to register all the permissions the application needed. That was called static consent. We just went through that a minute ago. The user had to consent to all of those things statically, but with V2, we can now send scopes that you want at the time you want them. We don't have to ask for them all up front. That's the dynamic consent. We're also going to change the contents of the ID token. This is the token that is going to be included with the response for the login that contains information about the current user, like their email address and their name, etc. And this is going to better conform to the OpenID Connect V1 specification. For example, we're using things like preferred username claim instead of a claim called UPN. And also in the past, if you needed a client application or a single page application or a web app or a web API or a daemon service, we had to create multiple Azure AD registrations and wire up each of the relationships between each one of those. And it was a bit of a pain. But now in the V2, this now is going to enable us just one app registration across a single logical application. And we can then open up all the different areas that we support for the different applications, such as representing a native and a web application if we wanted to. For more information, you can use that link at the bottom of the slide to learn more about the V1 versus V2 key improvements. Now let me talk a little bit about working with the different SDKs when it comes to Azure AD. Now the nice thing about this is that you really are going to self-select yourself into which one you're going to use. If you're using the V1 authentication endpoint, you have to use the Azure Active Directory Authentication Library, or ADAL. It only works with V1. If you're going to be using the V2 endpoint with the dynamic consent and some of the other things we've talked about, which is the recommendation from the Microsoft Graph team, you're going to be using the Microsoft Authentication Library. This targets the V2 endpoint. It's got a new conceptual model of two different kinds of applications. One's called a public client app and one's called a confidential client app. A confidential client is one that has runs in a web experience where you can put both the client ID and the secret in the application. Where a public client application is one going to be more like a native app, where I'm not going to be able to provide the secret. I'm only going to be providing the client ID. We also have a couple different platforms on where this is supported. There's MSAL.net for .NET Client, Windows Store, ASP or .NET Core, Android, iOS, Xamarin, Universal Windows platform. There's a JavaScript implementation, an Objective-C implementation for iOS and macOS, and an Android implementation as well. Now, where are we going to register our applications? This has changed a little bit over the years, but now where we would recommend that you go is to go to the Azure AD admin portal. That's at aad.portal.azure.com. Now, there's a bunch of advantages to using this. First advantage here is that you don't need to have a Azure subscription to get to the Azure AD admin portal. You can log in with either a Microsoft account or an Azure AD account. And you'll see in the demo, when we log into this, it looks like the Azure portal, except the options of all the different Azure resources that are available to us are all gone except for Azure AD. This new admin portal is also going to allow you to create and manage both V1 and V2 style Azure AD applications. So you can have access to both the V1 and the V2 authorization endpoints. You're also going to be able to leverage either ADAL or MSAL for authentication. And again, as I said in the last slide, that really is going to be dictated based on what you end up doing with your using either the V1 or the V2 endpoint. But because we're dealing with a Microsoft Graph, as I said before, you really are going to want to focus on using the V2 endpoint. So what does it look like? Well, you're going to go to the Azure AD admin portal and you're going to create a new application. So here I give it a name and then I specify what account types are available to me. So I could say that I want to use, this is where you're really going to pick, are you going to support work and school accounts in Azure AD or Microsoft accounts? And the first two choices that you see there with accounts in the organization directory only or organizations in any organization directory, that basically is saying, is it multi-tenant or single tenant? The first option is saying single tenant, meaning only people inside of my Azure AD or inside of my organization can use this app. The second one is multi-tenant, saying the app's going to be registered in my Azure AD, but anybody can use it that has Azure AD. And then the last one is saying really anybody, both anybody in any Azure AD and anybody with a personal account, a Microsoft account or an MSA, such as a Skype account, an Xbox account, or an Outlook.com account. Once you've done that, your application's been created and you're going to have an application ID. So you're going to grab that ID and copy that down. And then you're going to have these redirect URIs. And this basically is going to say, once someone logs in, where should they be sent or what valid places can they be sent? And at the top, you see that there's a web option. And that's where if I was building a website, where would I redirect them to after they signed in? But that doesn't work on a mobile experience or on a native experience like on the desktop. And so instead, we're going to choose this first option here, which is using MSAL, which basically is going to have a special kind of a code that includes the ID of the application that the native SDKs are going to understand how to work with. Now the app registration from the Azure AD admin portal, what you're going to do is once you log in, you're then going to go in and create your application using the portal. So once you create your application in the portal, you're then going to be presented with an overview of your application. So here you're going to copy the application's ID. Now it's hidden from the slide that you see here, but you'll see that in the demo in just a minute. But we're going to make sure you grab that ID. You're then also going to set up a redirect URI. And so in that case, you have to have a native platform that you're going to be adding, that it's a special string that the UWP app is going to be looking for and to know that you're coming back from Azure AD. So how do we implement Azure AD authentication inside of a UWP application? You're going to add in the Microsoft Authentication Library .NET SDK to your application. Azure AD is going to provide a .NET implementation of the MSAL library. You're going to add that using NuGet. And what's nice about this is that the MSAL navigation or library is going to handle all the integration with .NET to use the default browser to display the Azure AD login and the delegated consent experience. You want to make sure that you're using the most recent version of the application or of the library. You'll find the library as the Microsoft.identity.client library, and you want to make sure you're using the most recent one. We'll go through that in the demo in just a few minutes. So now, in the demo, we're going to do two things. We're going to first go create an Azure AD application using the Azure Active Directory Administrative Portal, and then we're going to go integrate the authentication libraries and do the configuration we need to set up in order to add authentication to our application. So let's go ahead and dive into the demo and do that now. In this demo, we're going to integrate Azure AD into our UWP application that we saw in the previous demo. The first step to do that is to first go create an Azure Active Directory application. So what I've done is I've logged in to the Azure AD administrative portal. And once I've done that, I'm going to come over here to my app registrations and I'm going to create a new app registration. So I'm going to go ahead and call this my graph tutorial. And I'm going to select that we can use any account for testing this. And then I'll just go ahead and click register to go ahead and create the application. So once the application has then been created, I'm going to create a copy of the client ID. I'm going to need this later. So let me go ahead and just make a note of this. Now, once I have the client ID, the next thing I need to do is I need to set up some redirect URLs or redirect URIs. And so that's going to be a little bit farther down. Oh, sorry, that's right here at the add redirect URIs. I'm going to go ahead and click on this. And when I do this, it's going to give me a list of suggested URIs for the different public clients. So by default, we would usually be able to type in or select one from this list right here. But in the case of what we're doing right now, that's not going to be an option. The one that we're looking for is not going to be presented here. So instead what we're going to do is I'm going to come over here to the redirect URIs, and I'm going to specify a public client for mobile and desktop, and I'm going to type the following in: URN:/IETF:/WG:/OAuth 2.0 OOB. And so this is what we use for a UWP application, is this string that you see right here. So once I've done that, I'll go ahead and click save. And now my app has all been set up. And now the next step is going to be to go to my application inside of Visual Studio and to start configuring it to use the authentication library. All right, in this section, we're going to extend the app from the previous section that's going to support authentication with Azure AD. This is going to be required to obtain the necessary OAuth access tokens to call the Microsoft Graph. And in this step, we're going to integrate the AAD login control from the Windows Community Toolkit into our application. Now, you saw we had already created our Azure AD application. So what I'm going to do is come over here to this resource file. And what I'm going to do is grab that ID for our application, and I'm going to paste that into this section right here. So I've got an app ID that's being defined, and I've also got some scopes that are also defined with this as well. Now, once that's done, I'm now going to go configure the Azure AD login control. So if I come over here and look at the main page .xaml file, actually, if I need to go to the code behind for this guy. If I go into here, I want you to take a look at some of the code that we've added for this. So let's go ahead and go full screen to make it easier to see. So here what you can see I've done is I'm loading in the OAuth settings. So I'm loading in the settings, the OAuth settings from that resource that we created, or that was created. And then I've got a reference to the app ID and then all of the scopes. So we got all that stuff that's already set up. What I'm checking to see is, assuming that I have these values, which we do, I'll come down here and I'll initialize the graph. So what I'm doing is I'm initializing the graph using the V2 authentication model, and then I'm initializing it by saying app ID, passing in the current user profile, and I'm splitting the scopes based on a space. As you saw a minute ago, I had two scopes and there was a space separating each one. Once I've then navigated, or I've then logged in, I'm then going to navigate to the home page. Now, this code is going to load all the settings from my OAuth.resource file and initialize the global instance of the graph. Now, it's not having me log in just yet. But what I want to do is I want to add in some sort of a handler into my login control. So if I look at the right here, my sign in completed on this. So I've got this where I'm going to set the auth state to true if sign in has been completed or completed successfully. And I'm going to navigate to the home page. Otherwise, I'm also going to set the auth state to false and navigate also to the home page. Now, when I do this, I've come over here to my main page.xaml, and if you take a look at the login control that we have, you can see I have a sign-in process that's been set up both for the sign-in process going this way, or for the sign-in completed, and for the sign-out completed. So those are the two methods that we have set up here. Now the next thing I need to do is inside of the homepage app, what I'm going to also do is inside of here, what I'm going to specify is if the user is currently authenticated, where it says that they've been authenticated, then I'm going to say, go ahead and use this to select the view. So we know that they will have already been authenticated and we'll be able to access the calendar. So let's go ahead and let's run this. I'm going to switch this back over to the 64-bit emulator. I'm going to go ahead and start the application. All right, here we go. Now there's the control, the sign-in control. So let's go ahead and click on that, and it should be able to log in to our site or into our Azure AD application. So I'm going to go ahead and let's paste in our login, and I will do the same with my password. And now I've never used this, so I'm going to go ahead and say that I want to grant these permissions. I have to go through the common consent framework the very first time to ensure that I want to accept this. So I'll go ahead and say accept these permissions. And we should see, there we go, cool. So it's working. So we can see that we're successfully logging in with this account. And then I can select it and sign out, and everything is working exactly as we would expect. Cool. So now everything's been set up for this. Now the next thing we're gonna have to do is we need to start integrating in the Microsoft Graph. So we're gonna see how to do that in the next section. In this last section, we're gonna look at integrating the Microsoft Graph .NET SDK into our UWP application. We're going to look at an overview of the Microsoft Graph .NET SDK. We'll talk about the Graph Service Client and then how to go about making requests. The Microsoft Graph REST API is always available to every kind of an application. Doesn't matter the language, the framework that you're using, the platform, because all it depends on is just an HTTP request. But the Microsoft Graph .NET SDK abstracts away the specifics of calling the REST API, and you can learn more about it at nuget.org/packages/microsoft.graph. It handles updating the HTTP request headers and the other details that are required by the REST API. And furthermore, it also provides a fluent API for creating Microsoft Graph requests. So how do we integrate the Graph into UWP applications? You're going to add the Microsoft Graph's UWP.NET SDK to the application, and this is going to provide a .NET implementation of the SDK. Similar to the MSAL SDK, you're going to use NuGet to add the Microsoft Graph .NET SDK to your project. So in this case here, you can see that I'm adding it using the NuGet Explorer inside of my Visual Studio experience. You can also take a look at the SDK documentation for additional steps that may be required depending on the size of your project if you run into issues. So how do you use the .NET SDK? Well, here's a little snippet showing you what it's going to look like. So in this case here, I'm creating an instance of the Graph client. I'm doing that by having a method called getAuthenticated_client. What that's going to do is that's going to be using the authentication helper, or specifically that's going to be using the delegate authentication provider to make a request out to Azure AD using the Microsoft Authentication library, which is all included in the authentication helper that we're going to create. And that's going to include or add in the header value, an authorization header value of bearer space access token that we're going to use to talk to the Microsoft Graph. So in this last demo, we're going to see how to integrate the Microsoft Graph .NET SDK into our UWP application to go fetch a bunch of data for the current user and display it inside of our UWP application. Or in this last section of the screencast, we're going to incorporate the Microsoft Graph into our application, and we're going to use the Microsoft Graph .NET SDK to do that. So I showed you earlier how we had already added in the Microsoft Graph .NET SDK into our project. So if we come over here and we look at our calendar page, we create a new calendar page here. If we look at the code for this, what you're going to see is a couple of references here to the Microsoft toolkit, the community toolkit, and to Newtonsoft, which is going to help us with our processing of JSON. Now I've also got a page here, or a function here called show notification, and this is going to show the main page that contains the in-app notifications, and then it's also going to show the notification control or initialize it, and then go ahead and show this. In the onNavigated_to event that we're going to override, I'm going to get a reference to the Microsoft Graph instance of the client, and then I'm just going to use that to go ahead and make the calls to the Microsoft Graph. So you can see here, I'm just going to go get all the data from those events, and then I'm going to bind those events to the current page on the events list, the grid that is going to be created for the UI of my application. So if I come over here and I look at the XAML file for this, you'll see here that I have a grid set up called event list, where it's got just a data grid that's got columns, and I'm going to be binding those columns to the different elements that we see here. And I've also created a little utility here called the converter, this little time zone converter, and all this does is it's going to convert a time to different time zones based on what comes back to me as like a UTC time or not as a UTC time. And you can see that I've added a reference to that right up here as one of the options. You can see this guy that's being created is going to be referenced right down here inside of the binding that's being set up. So let's go ahead and let's run our application, and let's see this application run. Go ahead and run. So our application is now loading, and once it loads, what we'll do, first step is going to be to log in. So let's go ahead to our sign in button, and let's go ahead and sign in to Azure AD using the same account that we tried earlier. So I'll just use this account, and let me go grab my password. And now that I've gone ahead and signed in, you can see I've signed in here. Now I can go click on my calendar, and so we should see a list of all of our calendar items. And sure enough, we do. We can see a list of all of our calendar items that are coming back from the Microsoft Graph. So this is really easy. You can see it was not that hard to go through and to set up what our navigation was, how our navigation was going to work, and then how to navigate or to redirect over to Azure AD to go have the user log in. And then once they've logged in, we then went in and added in support for the Microsoft Graph to go fetch data from the Microsoft Graph and display it inside of the UWP application using the Community Toolkit grid control. Now we've reached the end of this screencast for this module. You've seen a lot about how to do development with the Microsoft Graph based on the topic that we've covered here. Keep in mind that everything you saw here inside the screencast accompanies a training module where you can find slides and hands-on labs and all the final solutions that we showed you in the demos inside this screencast. So if you want to learn more, I'd recommend you check out the module associated with this screencast. Again, if you remember, the demonstrations that we showed you in this screencast, they don't walk you through every single step of building the application. Rather, we just look at the final solution that we've built and we see it running, which you can expect to see. If you want to see how to go about building a solution just like this, go look at the hands-on lab exercise that accompanies this module, because each of the demos corresponds with a specific exercise from the hands-on lab. So we have steps where you can walk through each one of these things. Again, one of the reasons we don't do all of the individual steps in the screencast is because things change on a very rapid cadence in this new cloud world, and different dependencies change, version numbers change, maybe a couple steps in screen caps are going to change as well in the hands-on lab. And so we keep the hands-on labs updated every couple months. But the videos would get out of date really quick if we tried to do that. So to save a little bit of time, we've just showed you the final solution, and we maintain the hands-on labs that you can take advantage of. I hope you got a lot out of this. There are a lot of other training modules associated with the Microsoft Graph that I'd recommend that you definitely take a look at. We've also got a couple additional links here that are at the end of the slides in the training module where you could use to learn more about this technology. So again, hope you got a lot out of this and you enjoyed this screencast. Thank you very much for taking the time to watch it.